Sometimes we want to describe a data set, and some of the best ways that we can describe it are to describe where it's located. And what I mean by that is, where is it located on like a number line? So we can talk about the average or the mean of the data set to tell us kind of where it might be centered. We can also talk about the median, which tells us another way of telling where the center of the data set is. And we can talk about percentiles, so we can get a feel for where certain chunks of the data are. So we're going to take a look at finding all three of those things today. The first thing we're going to talk about is the average. So to find the average, which is also called the mean, what we're going to do is we're going to add up all of our data values. So add all data values and divide by the number of data points. So what this looks like, if I have a data set that's D1, D2, D3, all the way up to Dn, so there's my data set. Then the average, which I'm going to write as A, is going to equal D1 plus D2 plus D3 plus all the way up, adding them up to Dn, and then I'll divide by n. So we're going to add up all the data points, and then we're going to divide by n. So this works for us, but sometimes we can actually do things a little bit more streamlined. So let's take a look at my chart that I have up here. So I have a data set that I'm given the data points and then how many of them there are for each. So if I want to know what it equals, what my sum equals of all of my data points, I'm going to find that sum by taking the data point, so data point 1, and multiplying it times the frequency. So here's data point 1, and here's its frequency. Then I'll take data point 2 times its frequency, and I'll add these things together. And I'm going to do this for all of the values that my data takes on, so I'll be going up to some data point k and its frequency. So in my example, I'll have 1 times 1 plus 6 times 1 plus 7 times 2 plus 8 times 6 plus 9 times 10. And I'm going to keep on doing this until I get to 16 times 1 plus 24 times 1. And now, at this point, you can put this into a calculator, and you'll find that this sum actually equals 814. So that's the numerator of the fraction that I'm going to use to find the average. Now, the other thing that I need to know is, what is this n? What is this number of values that I have? To find that, I'm going to add all of my frequencies together, because this is saying I have this score once, this one twice, so there's 4 data points in those first 3 columns that I have here. So n is going to be frequency 1 plus frequency 2 plus frequency 3 all the way up to frequency k. So for my example here, I'm going to have 1 plus 1 plus 2 plus 6 plus 10, and I'll be doing this until I get to my 1 and 1 at the end. So when I add up all of these values, I'm going to find that n equals 75. So now all that's left is for me to find the average. So to find the average, I'm going to take my sum and divide it by n. So I'll take 814 and divide it by 75. And when I do that, I'll find the average score of about, I'm going to do a little rounding here, 10.85 points. Now, for the other things that we're going to do today, when we get a data set, we're going to want to first put it in order. So here's a data set that has 15 values in it, and it's a data set of GPAs, and I'm going to first put all 15 of these in increasing order. So now that I've placed these in order, I'm going to number them so that I know what is the first value, what's the seventh value, without having to count them every time. Now what these numbers are is locators. And what these allow me to do is locate the value that's in a certain position very quickly. So say I wanted to find the 80th percentile for this data set. The first thing I would do is put it in order, and I would put out all of these locator numbers to help me find it. Now, the locator that I'm looking for the 80th percentile is going to equal 80 divided by 100, or the decimal form of 80%, times the number of data points that I have. So I have 15 of them. So this is going to be 80 over 100 times 15. And I'd plug that into a calculator. And when I do, I'm going to get 12. Now, what a percentile is telling us is that 80% of the data falls below that value. So this right here is telling me that position 12, this one right here, this is the 80th percent, right there. So percentile, since it says that 80% fall below the value that is the 80th percentile, that means I need to bump the 80th percentile up just so it's above that 12th value. So the 12th value is truly less than my 80th percentile. So the common way we do that is we say that we want to find the 12.5 value. So what we're doing, we're trying to find data point 12.5. What this is saying is to take data point 12 and data point 13 and to find the average of them. So we're going to divide by 2. So we'll do data point 12 plus data point 13, and we'll divide by 2, and that'll give us the data point that's halfway between data point 12 and 13. So in this case, I'll do 3.82 plus 3.88 and divide by 2, and I'll get 3.85. And that right there will be my 80th percentile. Now, let's look for the 55th percentile. So similarly with this one, we're going to find our locator by doing 55 divided by 100 times 15. Now when we multiply and divide this, we're going to end up getting 8.25. So we have a locator value of 8.25, so a little bit more than 8. So 55% falls in here. Now, we don't have any data points there at our 55%, but with the potential for more data to come in, and that something could be there, what we do is we go up to the next data point that we have, and we make that our 55th percentile. So that guarantees that the value that is the 55% value, even though it's not one of our data points right now, we have it that 55% of our data is below our value. So what we're looking for here is going to be our data point, and we'll round 8.25 up to 9. So in this case, it'll be 3.67 will be our 55th percentile. Now, the next measure of center here, finding the center of our data that we're going to talk about, is the median. So when we talk about the median, what we're talking about is the value in our data that half of our data falls below it and half of our data falls above it. So in a way, the median is kind of like the 50th percentile. So when we're finding the median, we're going to put our data in order. Luckily, here I have this frequency table deal again. So it's already in order for me. And then what I'm going to do is, if n is odd, the median is my data point at the n plus 1 divided by 2 position. Now, if n is even, the median is the average of my data point at position n divided by 2 and my data point at position n divided by 2 plus 1. Now remember, in this data set that I have up here, my n value is going to be 75. So it's odd. So I'm looking for the median, which is going to equal my data point at position 75 plus 1 all over 2. So this is going to be my data point at position 38. So to find this, I can look and see where is position 38. So this is position 1, that's position 2, this is 3 through 4, this is 5 through 5, 6, 7, 8, 9, 10. 5 through 10 gives me 6 positions there. So this will be 11 through 20 will give me 10 positions there. 21 through 36 will get me 16 positions there. 37 through 49 will give me 13 positions there. 50 through 58 gets me 9 positions there. 59 through 66 gets me 8 positions there. 67 through 71 gets me 5 positions there. 72 through 73 gets me 2 positions there. And then lastly, 74 and 75 positions. So if I'm looking for position 38, I'm looking in this bin of 11s that I have. So my median score is going to be 11. So now, the same way the median is the 50th percentile, we're going to have a thing called the first quartile. And the first quartile is the 25th percentile. So if we wanted to know what the first quartile of this data set is, we would be looking for the locator at 25 divided by 100 times 75, which equals 18.75. So remember, for the percentiles, we round up if we get a fraction like that, or decimal like that. So I'm looking for D19. So my data point in position 19. So if I go back to my values I found, 19 falls in my 11 to 20 band. So this value is going to be 9. Now, the third quartile is another interesting value to me, and that is the 75th percentile. So we can calculate this the same way by using the locator value and then determining it, or we can look at it and say the 25th percentile should be the same distance from the 50th percentile as the 75th is. And so we can look at it and we can say, I'm looking for D38 plus the difference between 38 and 19. So I'm looking for the data point at position 38 plus 19, or position 57. So I can look in my bands here that I made, and I can find that 57, that position, falls in my 12, my band of 12. So my value there is going to be 12. Now, it's a common thing that we get asked for the 5-number summary of a data set. When we do, what we should give is the minimum, or the smallest value, the first quartile, the median, the third quartile, and the maximum. And when we do this, we are giving a picture of what this data set looks like. So in this case, if I was looking for the 5-number summary of my data set, my minimum score is 1. My first quartile, I found the score was 9. The median was 11. The third quartile was 12. And the maximum score is 24. So with a 5-number summary, one of the common ways that I illustrate it is by using what's called a box plot. Now with a box plot, you need a number line that has numbers on it in even increments. With my box plot, what I'm going to do is I'm going to look for my median value of 11. So here I am at 11. I'm going to make a vertical bar at 11. And that vertical bar is going to represent my median. And I don't make it touch the line, I put it above it. And a lot of times I'll label the value that my bar is at. So there it is at 11. Then I'm going to repeat this for my first quartile and my third quartile. So at 9, I'll make a vertical bar there also. And I'll label it 9. And at 12, I'll make a vertical bar. And I'll label it with a 12. Now, these 3 vertical bars, I attach the top of them with a horizontal line, and attach the bottoms of them with a horizontal line. And that makes my box of my box plot. Now, the other thing that I need in a box plot are things called whiskers. So the whiskers go out from the first quartile down to the minimum, and from the third quartile out to the maximum. So I'm going to plot my minimum point at 1 with a dot, and I'll connect it with just a line headed into the box, and that's considered a whisker. And then I'll also make a dot at my maximum of 24, and I'll connect it, and I'll label these values my 24 and my 1. So if I'm looking at this data set and I get this 5-number summary, what this is telling me is that the data was fairly tightly grouped around those scores between 9 and 12. And then there were scores out beyond that on either end, but those were more spread out probably. So that's the picture that this 5-number summary gives me along with the box plot.